You know, our planet is never, ever standing still. It's constantly being shaped by these incredibly powerful invisible forces. I mean, from the churning liquid metal deep in its core to the massive continents just sliding across its surface, Earth is one dynamic world. So today, we're going to dive into the secrets of these incredible forces. So let me ask you this. What if you pulled out a compass and instead of pointing north, it pointed straight to Antarctica? And no, this isn't science fiction. It's actually a reality from our planet's past and maybe a glimpse into its future. This one kind of strange idea opens up the whole incredible story of Earth's magnetism. Okay, so to understand how a whole planet can just flip its magnetic poles, we really need to start with the basics. So our first question is super simple. What exactly is magnetism? At its heart, magnetism is a fundamental force of nature. It's what allows a magnet to pull on certain materials, like iron, by creating this invisible area of influence all around itself. And we call that a magnetic field. So any magnet you've ever seen has two poles, a north and a south. And the number one rule here is that opposites attract. A north pole will always pull a south pole closer, but if you put two north poles together, they'll push each other away. This super simple principle, well, it's the key to understanding everything from a magnet on your fridge to the magnetic field of our entire planet. All right, so we've got the basics of a little bar magnet down, but what happens when you scale that up? I mean, way up to the size of a whole planet. Let's explore Earth's very own magnetic field, a phenomenon we call geomagnetism. And that right there is the crucial point. For all intents and purposes, you can just think of Earth itself as one enormous magnet. It has its own north and south poles and this massive magnetic field that stretches way, way out into space. But here's where it gets a little tricky. The geographic North Pole, the spot our planet spins around like a top, is not the same thing as the magnetic North Pole, which is where your compass needle actually points. They're close, for sure, but there's an offset. And here's the kicker. While the geographic pole is fixed, the magnetic pole, it's always on the move. It wanders. So that's got to make you wonder, right? If the Earth isn't some giant solid bar magnet just floating in space, where in the world does this incredible planetary field come from? Well, the answer lies deep, deep beneath our feet. Okay, picture this. It all starts deep inside the Earth. Our planet's core is this spinning ball of liquid hot iron and nickel. Now, as this molten metal churns and moves around, it generates these incredibly powerful electrical currents. Then you add in the Earth's rotation, and that spin organizes all those currents into a massive, self-sustaining magnetic field. It's called a geodynamo, and it's basically a planet-sized electric generator. And this is where we get back to that crazy idea of your compass pointing to Antarctica. Because that liquid core is always churning and sloshing around, the magnetic field it creates isn't stable at all. In fact, over millions of years, the poles have completely reversed. North has become south, and south has become north. And this isn't some rare one-off event. It's a regular feature of our planet's history. So why should we care? I mean, what's the big deal? Well, this invisible field is absolutely vital. It acts like a giant shield, deflecting dangerous charged particles that are constantly streaming from the sun. Without it, life on the surface would be impossible. It's also, of course, the whole basis for compass navigation. And get this, many animals, like migratory birds, actually have a kind of built-in compass, a biomagnetism that they use to navigate the entire globe. That churning core is just one piece of our planet's very dynamic puzzle. The motion isn't just happening deep inside the Earth, it's also shaping the very ground we walk on. And that brings us to the next chapter of our story, the great mystery of the drifting continents. For centuries, people who made maps, and scientists too, noticed something really peculiar about the world map. It looked like the continents could fit together, almost like pieces of a giant jigsaw puzzle. Now, the journey to figuring this out took a really long time. It started with just a simple observation over 400 years ago. Then, in the early 20th century, a guy named Alfred Wegener proposed this idea of continental drift. But honestly, he was mostly laughed at because he couldn't explain how it was happening. It took decades of more research from scientists like Arthur Holmes and Harry Hess to finally find the proof they needed to solve the puzzle. And this is the observation that started it all. Way back in 1596, a mapmaker named Abraham Ortelius looked at his maps and just noted that the coastlines of the Americas, Europe, and Africa seemed to line up. He actually suggested they might have once been a single, bigger block that had been torn apart. I mean, what an idea! It was completely revolutionary and so far ahead of its time. So how did this centuries-old puzzle finally get solved? Let's take a look at how all these different ideas came together to form one of the most important theories in all of science. The solution really clicked into place piece by piece. Wegener told us what was happening. The continents were drifting. Arthur Holmes explained how it was happening. These slow-moving convection currents in the hot, soft rock of the mantle were the engine driving the whole thing. And then Hess delivered the final knockout proof. He discovered that new ocean floor was constantly being created at these mid-ocean ridges, literally pushing the continents apart. And in 1967, all these ideas were finally combined into the groundbreaking theory of plate tectonics. And really, this is the big takeaway. From that swirling liquid iron creating our magnetic shield to the massive tectonic plates sliding across the surface, our planet is not just some static rock floating in space. It is a living, breathing, dynamic system that's in constant, powerful motion. So I'll leave you with this final thought. All the forces we've talked about today, they are still at work right now. The magnetic poles are wandering, the continents are moving. It really makes you wonder, doesn't it? What will the map of our world even look like millions of years from now?